Hey everybody, it's Mr. N here, and we are back with another lesson. This is 1-1 for Geometry and Big Ideas, and the lesson is on points, lines, and planes. So let's get into it, and the first thing is a point. First of all, a point has no dimension. Now, I can choose anything to be a point. I can choose this dot. Oh, there's my lightsaber right there. I could choose that dot. But the reason has no dimension makes it an undefined term. So what do I mean by no dimension? Well, what if I made my point this big? What if I made my point that big? What if my point was the size of an atom? And I'm talking about that. What if my point was the sun? What if my point was a galaxy? So it has no size and there's no dimension to it. We typically represent it with just a dot, and we label that dot. We'll call it point A. So now I'm going to go ahead and erase this right here. And I'm going to talk about something here that I always like to introduce when I start teaching geometry to you guys. Just the concept of when we say it's undefined, has no dimension. So this is really important that you understand that it is an undefined term. And we're going to talk about that in detail in a little bit. But to just give you an idea of how things can be undefined, how things can vary size-wise from a small point to a large point. Imagine I'm sitting here in a chair and just relaxing. And imagine if you were the size of an atom. Okay, you would be able to, and you were in this part of the chair right here. If you were the size of an atom, so if you shrink me down to the size of an atom, which I can't do with the software, but if I was shrinking that small, to me there's going to be a ton of space in this chair. A ton of space. So I would look around me and I would see a lot of space. But me being as big as I am, I'm not the size of a single atom, and so I won't see all that space in the chair. And you could take this a step further. And I'm sure you've probably heard this in your science classes, but technically I'm not touching this chair. I'm hovering on this chair. So even when I sit, I'm just hovering right there. So tonight at the dinner table, you could tell your parents, well, I'm just hovering in my chair. I'm not really touching my chair. And that's because the way an atom is made, with the electrons moving around it, they repel each other. So they're not going to touch each other. So over here, you are just hovering. So you can see there's a lot of geometry in science, and a lot of science revolves around the geometry of things. And this size example just gives you a relative idea of how things can vary, and they may seem different. If you're the size of an ant, the world is massive to you. And even if you're the size of a human being, the world is big. But then you get to be bigger and bigger, and planets, those are small when you're talking about the size of a star. All right, so that is a point. Now let's move on to the next one, a line. So a line is also an undefined term. Again, it's undefined because we can describe it, we can explain it, but there's no real definition because there's too many things that can vary with it. So typically when we express a line, we are going to say that we have a line, say right here from A to B, and I will say this is line AB, and I will put this arrow over it. And a line has one dimension, and it's represented with two arrowheads. Now that's different than a segment, and a line extends in each direction infinitely. Now, why is this undefined? Because we don't know where it ends. We have no clue where the line ends. We have no clue how thick the line is. It could be really thick, it could be really thin. We don't know. And because of these reasons, we're going to say it's undefined. And here is one key thing you need for a line. You need to have 2 points to form a line. So if this is point D, this is point E, I need a minimum of 2 points to be able to form a line. And the next undefined term is a plane. A plane has 2 dimensions. So a lot of teachers typically will draw a plane that looks like this parallelogram type of shape, but it does not have to be like that. I can have something that looks like this and call this plane A. Okay, it does not have a shape to it. The only requirement is that it extends in every direction infinitely. So it's 2-dimensional right here, and it extends in each direction infinitely. So this, whether it looks like this or like this, will keep going on forever. So one example I like to use to make a little bit more visual for you is imagine a piece of paper. Now imagine a bigger piece of paper and a bigger piece of paper and then a humongous piece of paper or a never-ending big piece of paper. It's thin and it goes on forever in every direction. So if you take a look at your ceiling, it's typically going to be a plane, the floor, the wall. So these extend without end. Now, to have a line, you needed 2 points. To have a plane, you need 3 points. And again, it's undefined because it doesn't have any shape to it. A plane can look like whatever. And it doesn't have any thickness to it. So it's really thin, could be really thick, we don't know. But it goes forever in every direction. And where is forever? We don't know where forever is. We just say extends indefinitely. We don't know where that is. So anyway, one thing to remind you, for a line you need 2 points. For a plane you need 3 points. So 2 points make a line, and 3 points will make a plane. And you can call it plane M, you can call it plane ABC, but you need 3 points, a minimum of 3 points. You could have called it plane HJKI, as long as you have 3 points. You can use a fourth, you can use a fifth, that's okay. But typically you only need 3 when you're naming it. So, to recap, 3 undefined terms in geometry are going to be a point, a line, and a plane, and I can guarantee you that I will be asking you for those probably on a test. So, and why are they undefined? Oh, my guy's not moving here because I had to ungroup him. Okay, well, not my guy, me. And they are undefined because they don't have size, they don't have a shape. They could be big, small, thick, thin. So that's the reason there. All right, so now moving on to some terms that are defined. So over here, let's move some of this out of the way. These are defined terms in geometry. A segment is a defined term. And it's a defined term because it has an endpoint on each end. We know where it ends. So since we know where it ends, we could say segment AB consists of endpoints A and B and everything in between, all the points in between. So consists of endpoints A and B and all the points in between. We can also name this AB like this with a segment. Remember, if I put the arrowheads on this right here, if I put arrowheads, that would make this a line, but without arrowheads, this is just a segment, and I could name it segment BA. So either way. Array is a defined term because we can come up with a definition that suits for every single possibility because it has one endpoint and it goes on in a direction forever. So one endpoint and goes on in one particular direction forever. So if I call this D and E, I could name this ray DE and I would name it like that. But notice I can't name it ray ED. I always start with the end point, and even if the end point was on this side like this would be ray BA. You start with the end point and then go in the direction that it goes forever. Then we've got opposite rays. Opposite rays right here share a common endpoint. So C is that common endpoint. So CA is opposite ray CB. So ray CA and ray CB are opposite rays. Okay, so let's move on to the next page. And here we have more define terms, if I use the word collinear, collinear means that all the points are on the same line. Coplanar would mean all the points are on the same plane, are in the same plane. So when I say collinear, suppose I have 2 points here. We'll say I've got point A and I've got point B, and I connect them, and then I have point C right there. Point C is collinear with points A and B. Coplanar would again be points in the same plane, so we need at least 3 points to be in plane. So if I had 3 points like this, A, B, and C, such as above, I can't make a plane out of this, right? So when I make a plane, one of these points has to be non-collinear, and then I can connect to make a plane. So then we've got non-collinear, non-coplanar. The word non means not, and they're not in the same line, not in the same plane. And obviously you know this word intersection, where 2 or more lines cross. Now, review of absolute value equalities and inequalities. I don't believe you have this on the homework, so I'm going to go ahead and skip this for now. And let's take a look. There are no additional examples. The examples that I have for you I'm going to do in class, but right now do not worry about these absolute value ones. We are not going to cover these at this time. All right, so hopefully this helped, and we will do more examples in class. See you there. So make sure to hit that like and subscribe button, and I'll see you in the next video.